Hello, everyone, and welcome to the Faculty of Engineering Graduate Studies Ask Me Anything event for the Department of Systems Design Engineering. My name is Sarah Landy. I'm the Manager of Graduate Operations for the Faculty of Engineering, and I will be your host for today's event. During today's event, we will be hearing from faculty, current students, and admission experts from the Department of Systems Design Engineering. We encourage you to use the Q&A button within your webinar screen to submit any questions you may have about our graduate programs for our panelists. You can also upvote questions submitted in the Q&A by clicking on the thumbs up icon. This shows us that many students are interested in the answer to that question. During the second half of the event, we will have a live Q&A session using questions that were pre-submitted as well as questions that are asked in the Q&A chat. Within the chat, my colleagues Catherine, Jen, and Emily will be answering questions you have as well as sharing helpful links, so keep an eye out for them. This event is being recorded and all information is current as of November 3rd, 2021. So let's get started. I'd like to hand it over to our panelists now. Please welcome the Associate Chair for Systems Design Engineering Graduate Studies, Professor Ihab Abdelrahman.
Thank you, Sarah. Okay. So I'd like to take you through a brief description of what we do in the Department of System Design Engineering and what are our programs like. Currently, we have a bit more than 200 students distributed among three programs that I'll be discussing shortly. We are expanding our faculty, have expanded over the last few years our complement to 44 and will continue to expand. We run really three programs: a professional Master of Engineering program, research-based Master of Science program, and that comes also in with a nanotechnology specialization for those interested, and a research-based PhD program that also comes with nanotechnology specialization. Our research-based programs, the students can specialize in them in one of 8 research fields, or in 2 of them, or they may not declare a specialization if they don't feel like it at all. The professional program students can specialize in one of 5 specializations that we'll describe shortly, or they may also not choose one of them and just get a generalized Master of Engineering degree as well. Next slide, please. So the research fields sometimes are grouped into so-called methodological and application fields. Most faculty work in more than one field, and some work in places that fall between them. They are listed in here: the modeling and simulation, vision, image and signal processing, machine learning and artificial intelligence, optimization and decision making. These are more tools-like fields. The application fields are biomedical, human factors and ergonomics. There is some overlap between biomedical and ergonomics, in fact. Mechatronics and physical systems, and a lot of our mechatronics and physical systems is biomedical flavored as well. Societal environmental systems. We're going to describe more of these applications in a minute. Next slide, please. The professional program specializations, we have 5 of these. So there was an earlier question about whether someone can specialize in human factors, and indeed that's one of the fields. There is also artificial intelligence and machine learning, biomedical systems, mechatronics and physical systems, or vision, image and signal processing. Each of these specializations come with a specified set of courses that the student should take, and a set of elective courses that they need to choose from that list, 1 or more courses. If they meet these conditions, they automatically get the specialization designation in their degree. So you need to plan ahead. Not all courses are offered at all times. So you need to know which courses are offered in which terms. We admit students all year round. So that means that depending on at which point in the year you enter the program, your path to completion will vary. You should be able to talk with our graduate coordinator, Ms. Jeanette Friend, about the details of this process or with me. She can advise you on the procedures. I can advise you on the academics of this. Thank you. Next slide, please. In the next few slides, I'll just introduce some of our faculty and the fields in which they work. So the first thing to know if you're going towards a research-based program is it's all really about your supervisor, meaning your supervisor is important, not just because of the things listed here, which are the more tangible things like this is the beginning of your career, the network you're going to create. This is the degree you're going to be getting. The quality of the supervisor research, their track record gives people impression about how rigorous and how good is your work. You're going to need your supervisors for letters of reference. They are the main guide of what you should be doing to train in the field. They are essentially your tutor. You need to look for someone who is working something you're interested in. The research is a significant undertaking. It takes a lot of time, effort, money, and you want to make sure that you're investing it right. You want to make sure also that you have a good match with your supervisor in terms of style. Some supervisors tend to closely supervise their students, others supervise from a distance to give them more space. I'm not sure that one style is better than the other, but they are distinct. And some students are more relaxed, more at home with the close supervision styles. Some are not. You want to check about that. The best way to check about that is ask around. Ask former students, ask current students. You can ask the supervisor, but quite frequently we don't see ourselves well. So it's not dishonesty, but it's hard for one to describe themselves clearly. Others can see us better. You should also take a look at your supervisor's or prospective supervisor webpage at the university. Quite frequently, these pages are not as updated as the Google Scholar pages. You also want to look at these. The recent 5 years publications would tell you very clearly about what they are doing, how they are doing it, and where they are doing it, and how good or reputable it is. Next slide, please. Okay, so I'm going to be talking about our faculty group with the closest field to which they are associated. As I said before, most of us work across fields. So we do have a group that works in human factors and ergonomics. This is made of Professor Barnes, Tsao, McGregor, and Samuel. They work in things like human-computer interaction, user interface, cognitive ergonomics, as well as more hardware type ergonomics as well. Next slide, please. The societal environmental system and environmental system right now is comprised of fundamentally 3 professors: Professor Altman Hall, Professor Poonam, and Professor Scott. They work across things that are all the way from scanning the ice surface in the Arctic to wastewater system, road systems, and large-scale type systems, studying these systems, designing them, optimizing them, supply chains, that's now very much in the news. These are the kinds of ways in which they work. Next slide, please. We have a large group of people who work in mechatronics and physical systems. So we work in sensors and actuators and energy harvesters and the like. They include myself, Professor Azad, Professor Hippler, Professor McPhee, and Professor Yo. Next slide, please. We also have large and growing group in biomedical fields. Like Professor Gorbet, she works in biocompatibility and biomedical materials. Professor Jiang works in brain-computer interface and ECG and EEG and similar fields. Professor Kaufman works on both biomechanics, rehabilitation, biomedical devices, as well as medical imaging related to medical fields and other fields as well. Professor McDonald works in somewhat of the social interface of hearing augmentation, and similar fields. Professor Maftoon is also in audiology field, but he is more on the hardware side and the simulation side. Professor Haji Reza works in biomedical systems, biomedical imaging systems, that is. And Professor Willett works with bone mechanics and bone replacement and things similar to that. Next slide, please. The last group I'm going to mention are the intelligent systems, artificial intelligence and machine learning group. It includes Professor Dottenhagen. She works in social robotic systems for rehabilitation and social type tasks. Professor Elias Smith, he works more on the neural system side of things and trying to understand how the neural system work or how you could create neural control systems. Professor Manbauer works on robotics and human-computer interface from the hardware side. Professor Nihaniv works also with intelligent systems on a more abstract mathematical approach. Professor Tribb is on robotics as well. Next slide, please. We have a very significant group that works in vision, image, and signal processing. It includes Professor Closey, Figoth, Wang, and Zelip. A lot of their work is also related to applying machine learning and artificial intelligence to images and signal processing. Next slide, please. So I'll turn it over to 3 of our graduate students to talk about their experiences and what they like and maybe dislike in the program. Thank you.
Hello, everyone. This is Jeanette. I'm an MNG student here, and I came to Waterloo after 5 years of work experience as a systems engineer. So the reason why I chose Waterloo was one of the first reasons is when you look at Waterloo, it's one of the best engineering colleges in Canada. And whenever you hear about Waterloo, you always hear about like a bustling and like engineering atmosphere, a sense of innovation. So that's what attracted me over here. And then another interesting fact was Waterloo has a very strong alumni networks. When I was working in States, few of my friends working in Google or Apple, they're like half of the floor is wearing Waterloo hoodies. So that's how strong the network is. And apart from that, in my personal opinion, I think immigration, especially for international students, I think immigration for studies to Canada is very well supported by the government, and they have very good programs for postgraduate work permit programs like that. Talking about systems design, why I chose system design. So in my entire life, I have been involved with a lot of multidisciplinary projects or activities that I did in the past, and system design fit perfectly. Like here, you can choose to do what you want and what would hone your skill better. In a way that it really complements your own skill sets. You have more flexibility. And being a mid-sized department, us as students, we have a very good opportunity to interact with faculties and develop or create more personal relationships. And they are one of the most helpful people that I've met over here. Next slide, please. So now all the students, when they are trying to decide on an university, which universities to select, one of the major things is also how's the life around the campus. So Waterloo is a small college town, and being a college town, it definitely is bustling with like that student energy everywhere. There's something or the other happening. Amazing food places around for the foodies out there. You can find a lot of different options in cuisines in and around. And for those who are like nature lovers, there's Waterloo Park right outside the campus, beautiful walks, uh, beautiful picturesque, and you can just go about in nature and find beautiful spots to just sit down and gather yourself back in. Thank you. That will be all from my side.
Hello everyone, it's Ebru Emir, and I'm a master's student here in System Design Engineering. So why University of Waterloo? Because when I was making research about universities and their graduate programs, I came across University of Waterloo and I saw that it was in the first 100 of university rankings. But I checked it when I was preparing for this presentation, but I think it's not in 100, it's in 150 or something like that. But yeah, it was one of the main criteria that I chose University of Waterloo. And why systems design engineering? Because it was related to my field, and I have a bachelor's degree in industrial engineering. So I thought the closest graduate program that I could find to industrial engineering was systems design engineering. And I also wanted to, do something that included both technology and humans and the social part of, technology, using and adapting to new technologies. So that's why I chose system design engineering, and under it I am more interested in the human factors and ergonomics side. And in terms of the research group, I am a member of the Advanced Interface Design Lab, which is directed by Professor Catherine Burns. And I can say that it's like my second family in Canada, because apparently I just spent 1 year here in Canada, and the only people that I know and socialize with are my lab mates and my supervisor. So it's, I think, fair to say that. And yeah, we have a lot of social gatherings together with the lab. We had a Christmas party which was held online through Teams, and we had a fall barbecue in the September. So it helps me get to know more people, get to know different research focuses, research ideas, and it helps me calm down in these hectic times. And what about finding a supervisor, and how did I manage to find a supervisor? So I used the University of Waterloo's contacting a prospective supervisor webpage. I think it was a web form, but it's not used anymore because I tried to find a link for you while preparing the presentation. I think it's not used anymore. So the only way you can find a supervisor is via email. And if you're already in University of Waterloo, you can maybe visit some of the prospective supervisors that you want to work with. But yeah, it's always good to check beforehand to see their availability. Yeah, there was lots of emailing back and forth and video calling, because I was in a different country back then while I was trying to find a supervisor. After filling out the web form, Professor Catherine Burns actually wrote back to me. She contacted me about organizing an interview for to understand my research interests. Next slide, please. And what about the graduate life? So I can say that unlike undergrad studies, graduate studies is more like self-sustaining, and you are more responsible from what you do, what you research, how you manage a research project. And I think it's fair to say that you are the captain in this boat. So it's your thesis, your graduate thesis. So you are the principal person responsible from that. The professor will not, will not be, tracking you down to see if you finished a project, for example. And yeah, apart from academic life, in terms of recreational events, I serve as the communications director at University of Waterloo's HFES student chapter. And in terms of the life in Waterloo, I really like Waterloo and Victoria Park. Victoria Park is in Kitchener. I picked up ice skating here in Canada. We visited the public square where they set up a public rink every winter. So we were going there every 2 or 3 nights in a week. And yeah, I really enjoy, traveling with the light trail, Iron Light Trail here in Waterloo. It's very nice to see around and, enjoy the landscapes, especially in fall. In terms of career aspirations, I'd like to go on with PhD studies, and maybe apart from the studying a PhD, maybe I can work a part-time job in a technology or preferably a robotics company. And yeah, these are all I have to say. I'm glad to answer your questions.
Hello, everyone. My name is Arvindravi, and I'm a PhD student in systems design engineering. The research areas that I work under are in brain-computer interfacing, EEG signal processing, and applied machine learning. And I work with Professor Ning Jiang, who's the director of the Waterloo Engineering Bionics Lab. And the research is interdisciplinary in nature, where it is at the intersection of biomedical signal processing, machine learning, and applied neuroscience. And my current project focuses on novel methods in brain-computer interfacing to induce and measure motor neural plasticity. So why I chose systems design engineering is I have a personal interest in applied machine learning and biomedical applications. Like, although my background is from ECE, I wanted to have a kind of a switch in domain, and systems design was like a perfect match to my interests. And also the research that happens here is interdisciplinary, so you can learn multiple different topics. And also there's a diverse group of faculty and students, like Ronit and Ebru had already mentioned. Some of the research activities and opportunities I've had. So some of my daily work involves innovation, like converting new ideas into a working system. And almost every day we're recording and collecting biosignals like ECG, EEG, and EMG, and analyzing them to build these kinds of systems. And it's a really intellectually stimulating and collaborative environment, like both within the lab and also among the different labs. So when you talk to other students, you get these different ideas which you might be inspired by and use it in your own research. I've also had the opportunity to collaborate with industry collaborators. For example, a company called Conditional in BCI research, and also had some opportunities to communicate our research through publications, through like journals and conference articles. Next slide, please. I was also part of the Systems Design Graduate Student Association, and I would encourage all of you to take part in the events. It's a very nice place for you to meet other graduate students, and we had the opportunity to host many events like technical talks, board games, and other sporting events. And I'm hoping we can get back to doing some of these once we are all back in person on campus. Other than that, in the Kitchener-Waterloo area, there are different things to do outside of academia. So here are some pictures where with some of our lab members, we went out in the summer to do some strawberry picking, which was very fun. There is a Grand River Rocks, so people who are interested in rock climbing, you can go there. And as Ronit mentioned, there are very good cuisines. So there's like a picture of our lab group at like a all-you-can-eat sushi bar. And also, I had an opportunity to present one of our research papers at a conference in San Francisco. So looking ahead, I envision a career in research in the areas of applied machine learning and biosignal analysis, and more generally, developing tools that can enhance the overall well-being of humans. And I'll be happy to answer any questions you have. Thank you.
Great, thank you very much. Unfortunately, our graduate admissions coordinator, Jeanette, couldn't be here with us today, so I'm just going to talk to you a little bit about the various programs in systems design engineering and some admissions information. So for systems design engineering, we have two types of master's program. We have the Master of Engineering program, which is a course-based program. It requires 8 courses to complete. You don't need a supervisor before you apply, and you don't need a supervisor to be accepted. It's a self-funded program, and should you find a supervisor upon arriving here and starting your MEng program, you are eligible to transfer into the MASC program. The MASC program is the research-based program for the master's. Its requirement is 4 courses. You don't need to have a supervisor secured before you apply, but you do need to have one in order to be accepted to the program. There is a guaranteed minimum funding for all MASC students, which I'll talk about in a little bit. And if you are an exceptional MASC student, you may be eligible to apply directly to our PhD program before completing your master's. Additionally, of course, there's also the doctoral program. So this is, of course, a research-based program where you're required to complete 3 courses in addition to your research. Again, you don't need a supervisor to apply to the program, but you do need one to be accepted into the program. You are provided, again, with guaranteed minimum funding for PhDs. So I'm going to talk a little bit more about funding. So all of our research-based programs come with guaranteed minimum funding, and this is regardless if you're domestic or international student, you receive the same guaranteed minimum funding. So for MASC students, the guaranteed minimum funding is $18,000 a year. And for PhD students, it's just over $24,500 per year. In addition to your guaranteed minimum funding, you can also hold a TA-ship. TA-ships, unlike in other faculties where a TA-ship is part of your funding, in engineering, it's in addition to your funding. So your guaranteed minimum funding may be higher as a result of holding a TA-ship. For domestic students, we also have what are called tri-agency awards. This includes Vanier, NSERC, CIHR, and SSHRC. And students who hold these awards will also get an additional top-up from the university. So not only will you get the value of the award, you will also get an additional $10,000 to $20,000 from the university just for holding that award. Additional funding opportunities that are available, again, for domestic students, we have $5,000 in entrance scholarships. We have very prestigious fellowships that are available, valued at $25,000 to $30,000, and the tri-agency top-ups, which I already mentioned. We have equal funding for international PhD students. So international students pay a higher tuition rate. And in order to offset that tuition rate, international students receive, in addition to their guaranteed minimum funding, the International Doctoral Student Award. And this funding offsets that tuition difference. So that this means that the international students receive the same after tuition income that a domestic student would. We also have around 148 international student awards that you're eligible to apply for. Lastly, we have a new fellowship available for domestic students. It's the Indigenous and Black Engineering and Technology Momentum Fellowship. This is a very prestigious PhD fellowship with financial support valued at $30,000, $25,000 from the university, and $5,000 top-up from the supervisor. If this is an award you think you might be interested in, we have the link posted on the screen here that you can visit as well. So you want to apply to systems design engineering. What do you need to know? Systems design engineering admits 3 times per year for fall, winter, and spring cycles. Right now, we're admitting for the next admission cycle, which is going to be fall 2022, and the deadline for that is February 1st. You, of course, if you miss the fall deadline, can apply for winter or spring. It should be noted that these deadlines are for completed application packages, and that includes your references and any test scores like English language proficiency or GRE that might be required. So how to apply? First thing you're going to want to do is explore those 5 programs that Professor Abdullah Rahman mentioned at the beginning of his presentation and decide which program is right for you. You're going to want to review the admission requirements for that program to make sure that you're eligible to apply. You're also going to want to review what application documents are required. So things like English language proficiency, resumes, supplementary information forms, portfolios, that kind of thing. You're going to want to contact a supervisor. While you don't have to contact a supervisor before you apply, you can do it after you apply. We do highly recommend that you start the contacting process as soon as possible to give you lots of time. Also, faculty members look for their names in applications. So when you apply, there's a space where you can put the names of faculty members you're interested in working with. Even if you haven't contacted them yet, at the application stage, we do recommend that you put in faculty members' names that you're interested in working with from the outset. You, of course, are going to need to apply through our online application portal. And once you've applied, you'll then need to upload your admissions documents. So those are going to be things like your GRE scores, your English language proficiency scores, CV, and supplementary information form. So that wraps up the presentation part of our event. So thank you very much to all of our panelists for presenting. We're going to begin the Q&A session. As a reminder, continue to submit your questions using the Q&A button within the webinar screen and upvote any questions that you'd like to hear the answer to. Our first question I'm going to direct to our 3 student panelists. We're very fortunate to have one of each of you from each type of program, which is great. So perhaps, Ronit, I'll start with you. Can you tell us what's the one thing you wish you knew now in hindsight before you applied? What would you give to our attendees in terms of advice?
Oh, I need to think about that. So what would I think there's not really much. I would just say concentrate on your admissions. I don't know, like it's a simple process. Unless someone, if Arvind and Ibru, you want to go first, let me gather my thoughts and I'll get back to you guys.
All right, maybe Ibru, do you want to go? And what do you wish you knew before you had applied that you know now?
Well, maybe I would want to, experience the city before applying, because I was in a different country and I didn't know what to expect when I came to Waterloo. It would have been a very crowded and big city like Toronto, which I really wouldn't want to live in. But unfortunately, it's a very, it's an open and green city with lots of parks and hiking trails. So I think it would be nice to see, to feel how it would be like living in Waterloo, like to a feel of the city and of the community here living. It was hard to guess it from a different country, but I think it would be really helpful before applying.
Yeah, like an exchange or something.
Yeah, exactly.
Yeah, that's great advice. Thank you. Arvind, did you have some wisdom you'd like to share?
Yes, so one thing that, so when I started applying, I applied from India, and because I was in a different time zone, I was kind of hesitant to contact supervisors, like potential supervisors. So I would say, please don't hesitate, just send them an email if they, they are always busy, but you can also maybe reach out to the grad students and then just don't hesitate to contact your potential supervisor. So that was something that I learned afterwards when I came here.
That's great advice. We always have lots of questions about contacting supervisors, so that's wonderful. Ronit, did you want to circle back?
Yeah, sure. So adding on to what Arvind said, it's like even I felt the same thing. We always think, oh, what are we writing for email? I would just say, just form your email and send it out. More people here are really helpful. They're there to help you guys out. Other than that, we also think about when we are thinking about what city we are going to. I thought being a big university is going to be really competitive, but now I'm happy that people here, it's a really tight group and everyone works with you, and it's a really good atmosphere and we have really good peers to better ourselves together. So that should be
Excellent.
good.
Yeah, that's great. Thank you so much for sharing. Our next question, I'm going to direct to our faculty. Oh, Ehab, yeah, did you want to add something?
And just a comment. I get the feeling that undergraduate students are thinking of the application process to graduate school in terms of undergrad school. This is not about your grades. This is about, especially if you're applying to Master of Engineering, it's pretty much about your grades and your work experience. But if you're applying for the research programs, it is about the supervisor being convinced or satisfied that you can be successful in their program. So the questions about what is the minimum acceptable grade really don't apply, because the question is, in the end, the supervisor in their mind, what you would consider reasonable or acceptable within their field. Not all of us have the same expectations for undergrad grades. Sometimes some of us would think, well, yes, the grades are low, but then they have these experiences, or it doesn't matter if it's below 90, I'm not working with them. So keep in mind, this is a whole different deal than applying to undergrad.
That's great. That actually sort of segues really nicely into the question I was about to ask Ehab, so maybe you can answer this. How do students who have little research experience and wish to apply to the MASC program strengthen their application?
They would have to show us what previous research exposure or experience they have had. In the end, as I'm saying, is if the professor is convinced, or the supervisor, prospective supervisor is convinced the student is going to be successful, I'm not about to put myself in place to judge about what would work in their field. Okay, so provided they meet our minimum standards and the professor thinks they are going to be successful, I'm quite supportive.
Okay, that's great. Thank you. Maybe I'll direct this one to you, Dr. Fegu. Would you ever consider taking a research-based student who didn't have a background in engineering, maybe something in science or something instead? Or are these students with more diverse backgrounds considered for systems design engineering?
They most certainly are considered. I mean, my area in sort of signal image processing, machine learning, relies fairly heavily on certain parts of engineering background. But students who do not have an engineering background can most certainly do graduate studies in engineering. So I definitely want to encourage them. We've had quite a number of students from different kind of backgrounds. I actually right now have two students, one with an undergrad in math and one with an undergrad in statistics. And I know certainly lots of undergraduate students with backgrounds in sciences would also come and do grad degrees in engineering. So it is for sure doable. Obviously, you need to look at what kinds of courses, what the expectations are from the supervisor, but I would encourage such students to apply. They would need to articulate why they're interested in changing, right? What is it about systems or engineering that attracts them? What is it about a particular research area? But certainly they're eligible to apply.
That's great. Excellent. Thank you very much. Ehab, I'm going to come back to you. We mentioned that students in the MEng program are eligible to transfer to the MASC program. Are there any limitations on when a student, like how soon they can transfer upon arriving if they find a supervisor?
No, as long as there is a supervisor and their GPA is within acceptable range, I have no problem. I'd approve it.
Great, thank you.
Now, when the record is going to reflect it is another matter. That will take some administrative procedure, but it should happen within the term.
Okay, excellent. For our graduate student panelists, we have a question regarding how you perceive your, I guess, your return on investment for the program you're in. So, you know, your career prospects and you know, what your degree is adding to that. Maybe could you speak to that a little bit? Arvind, maybe I'll let you go first this time.
Yeah, that's a great question. So initially I joined as an MASC student. So after I graduated, I was able to find an opportunity as a biosignal research engineer at an organization called Interaxon Muse, which also works in EEG signal processing and works on meditation and sleep related applications. So I was fortunate to have that same impact. Whatever I learned in my lab during the master's research, I was able to directly apply it at the workplace. There are many startups, I would say, around the Kitchener-Waterloo area and also in the Toronto area that are going into this kind of deep tech space. And so there are these career opportunities. And then if you're interested in research, academic research, so for example, myself, I came back after a year of full-time work as a PhD student. That is also open.
Great, thank you. Ronit, you mentioned that you had worked in industry prior to coming to your MEng. How do you feel that this has impacted your career prospects?
So while working as systems engineer, I thought going back to school was important because you need to update yourself with the current technologies. And then in terms of return of investment, again, I just started this term, so I won't be that great of a candidate to talk about ROI, but I've heard there for people who are doing their professional degrees here, there are a lot of opportunities in Waterloo itself and in Ontario as well. And apart from that, it's about developing yourself and learning the new skills that you want to in the first place. I think that's pretty much it. I'm not sure how to talk about ROI apart from that.
Yeah, no, that's great. Thank you very much. Ibru, did you want to add something?
Yeah, in terms of my my own specialization, specialty in human factors and ergonomics, I was looking at the charts and the statistics. They were mostly regarding the United States, but for human factors engineers, it's mostly preferred that they have a master's degree or a PhD degree to be able to work in that field. So I believe in my own field, it is mostly expected that students get a master's degree before they go into industry and before they work as human factors engineers. So it's not very common that after undergrad studies you are going to be HF practitioner or an HF engineer in the industry. But I would recommend a research-based program because what they mostly do is doing research about how humans could better interact with the technology and how the fit between humans and technology could be enhanced. So it's mostly research-based. So yeah, that's what I would suggest.
Great, thank you very much. I know this came up in the chat. And Paul, I think you may have touched on it in the chat, but you could speak to it now. Providing a strong foundation in human factors and ergonomics, students that are interested in this area of research, both for the MEng and MASC, is this, what kind of depth and breadth are students getting from this specialization?
Yeah, I was just looking at that question. So the answer would be, I think, fairly different for the MEng as opposed to the research degrees, not in terms of whether, but in terms of how. So for the MEng degree, prospective students need to realize that it can be fairly flexible what courses they choose. So they need to, I mean, there are sort of sets of specializations that are predefined, but students do need to take the appropriate kinds of sets of courses in order to get the kind of depth that would actually get you a strong foundation, as it was asked. Otherwise, yes, the Human Factors and Ergonomics group at Waterloo is one of the largest in Canada, and so has a sort of very strong sort of degree of research activity and a variety of graduate courses. So yes, there would not be many other places where you would get the kind of depth that you will find here.
Excellent, fantastic. Ehab, what kind of job prospects are available to students, especially completing the MEng program in systems design, and do many of them go into startups?
Our undergrads do a lot of startup work. Master of Engineering do not do as much because many of our Master of Engineering are international. They don't know the market yet. So it might not be, that's the main handicap, but there is nothing to prevent that. So the challenge really is if you want to do a startup, then you need to understand the market well to come up with something that has value in it and that you can sell.
Okay, excellent. Another question for you, Ihab. Could you just elaborate more on the difference between an MEng and an MASC for systems design? Like, just how do they break out?
Okay, so MEng is a shorter program, meaning typically you would finish it if you are going to take full or beyond load in a year, or at most you would need 16 months. You would pay your way, so it's more expensive. Master of Science typically takes 2 years. It's a longer slog, and the type of work is different. So in Master of Engineering, your work is studying your courses. There is a project-based course, so you get to do some training and applications, but not a whole lot. Master of Science, there are only 4 courses, but most of the work, really maybe 80% of the master's work is on research. So you focus on a narrow field and you go really deep into it.
Okay.
Both of them can prepare someone for industry, meaning for going directly to market rather than a PhD. But the type of preparation is going to be different. Master of Engineering is going to give you a wider preparation for the market. Master of Science is going to give you a much deeper preparation.
Okay, thank you very much. In terms of contacting a supervisor, which is something that comes up very frequently, and we've touched on it a little bit already. Yeah, maybe you can speak to students who maybe find a supervisor, the supervisor likes them, but doesn't have funding for them. Is it possible for students to pursue, for example, a PhD degree without the guaranteed funding?
Part-time, not full-time.
Right. Excellent. Okay, thank you. So part-time studies is the only way to study in a research-based program without funding. Yeah. Okay. Great. All right. For the MEng program, Ihab, are you able to take additional courses to complete multiple specializations?
No, you probably know this better than me because you know the procedures better than me. No, as soon as you finish 8 courses, if you have the requisite courses for a specialization, you graduate with that specialization. If you don't, then you graduate with a generalist master engineering degree. Now, if you need undergrad courses, you can take them. If you want to take courses not for credit, you can take courses not for credit to expand your background. But if you take courses for credit, as soon as you finish 8 graduate courses, you are done. Right, Sarah?
Yeah, absolutely. Paul, did you want to add something?
I was just going to check whether I had not actually heard that. So it is actually true that as of 8 courses, you're essentially done. At least at the research level, one has to submit intent to graduate forms and things like that. So I had assumed that an MEng student would kind of need to declare themselves done, that it would be possible to take a 9th or 10th course. But
there are strategic ways to take a 9th and 10th course, but basically once your degree requirements are met, which for an MEng student is usually through the completion of 8 courses, you would be degree complete. You still have to apply to degree complete. Ways to get around it, which I maybe shouldn't be advertising, or things like you don't take your 4th systems design course until it's your 9th course. So you haven't met your degree requirements because you still have an outstanding systems design course, that kind of thing.
Right.
So it is possible, but typically we see students completing after 8 courses. Where'd my question go? Okay. maybe Paul, I'll direct this one to you. If, again, on the thread of contacting prospective supervisors, if they were interested in a specific, working with a specific faculty member, and maybe their research background didn't specifically align with that of the faculty member, how are ways that they can reach that faculty member to convince them that they would be an asset to take them? Like, what steps could a student take to say maybe their background isn't in human factors and ergonomics, but
That's a difficult question. I mean, most professors get almost endless emails from students around the world. And so it is very, very difficult to make kind of a first impression. At the same time, I would absolutely encourage sort of prospective students to do the reaching out, right? I mean, if you don't reach out, it is very difficult to be noticed. So I think the best thing you can do is articulate your interests and your background as clearly and succinctly as possible. So keep in mind, professors get a lot of emails, and a lot of them will be from students who claim this and that. Be yourself, but be clear. Why is it that you're interested? What is the background that you're bringing? What's the passion? What's the project that you've done that's relevant? I think you need to sort of catch someone's attention. Once you have someone's attention, then it's a very different matter. Then, then they may look up your grades, or they may look up your record in the online system, or they may propose a short online sort of interview. At that point, you have the opportunity to say much more about your interests and your background. But it is a difficult challenge. You'll also should understand that as prospective applicants, I often get asked, if I don't have spot for another grad student, do I know other professors who are looking? It's a reasonable question, but you need to realize professors rarely know which other professors are looking for grad students, because we don't meet that often to talk about whether we're looking for grad students or not. So that kind of question is not likely to be very helpful. What you need to do is, the web pages lay out fairly clearly who's in which research area, who has which interests. You do the homework of seeing which professors have research interests or recent papers in an area that interests you, and you reach out to them. I think that's the main thing I can suggest. And don't try to overwhelm the person with a zip file with 20 different files in it with all your projects. No one wants to open that. Keep it short and to the point. A 20-line email that succinctly describes one or two projects plus a couple of interests and where they went to school is much more effective than long attachments that I don't have time to look through.
Excellent, great advice. Thank you very much. Ehab, can you outline maybe just at a very high level how many students systems is accepting maybe on an annual basis to each of the three types of programs?
So on an annual basis, we accept about 30 something in Master of Engineering, about 30 in Master of Science, about 20 something in PhD, these kinds of levels.
All right, excellent. Thank you very much. There is a question here that Ehab, I'm not sure you're gonna be able to answer, but if you can't, I can. Is a conditional offer letter given to an applicant if they fail to submit some of the documents in their application package? So if they don't submit an LP or they don't submit their
that you answer.
So I know there's interest in this question, which is why I brought it up. And I will say that students do need to have a completed application package in order to apply. If for some reason you can't get an LP test because, for example, the testing centers in your country are closed due to COVID, that's the kind of situation where you would reach out to your departmental graduate coordinator and they would be able to help guide you through other options that we have available. But that's going to be something that's done on a sort of one-off basis. Generally, students with incomplete applications that don't contact us and don't follow up will be unfortunately denied just due to being incomplete. We don't issue conditional offer letters based on maybe we'll see your transcripts or not. So that is an important thing to remember. All right. So for our current students, we're coming towards the end of our time here. What is something about your program that you like the most, that if to these prospective applicants that are trying to decide between, do I go to an MASC, do I go to an MEng, do I go straight to the PhD? What are the types of things that you like best about your program that you would recommend to students? Maybe Ebru, I'll start with you.
I think for me, it's the supportive nature of the lab, and you know, you get to see different projects, different theses, and different research ideas from your lab mates, and they all, you know, help to spark new ideas in your mind, and where you can, you know, look for different research focus, or what you can improve for the human computer interaction, or perhaps human robot interaction. So you get different ideas, and you get inspiration from your lab mates, from what they do, you know, having conversations with them, making discussions with them. So I love that I can, you know, talk with my lab mates, and I can reach them whenever I need help with any administrative issues or any research-based problems. So, yeah.
That's great. Thank you. Ronit, what about for the MEng program? What do you like most about that program?
Yeah, so talking about MEng, there are two things that were kind of deal breaker for me. So one was the short duration. Being a professional, I wanted to get my master's done and get back to field as soon as possible. So being a 16-month course, this was ideal for me. And the second part was the flexibility. Like we take 8 courses, so you can touch upon a lot of topics that you feel would complement the skill sets that you already have. You have a lot more say on what you want to learn and master yourselves in, being an MEng student, and that was the deal breaker.
Great, thank you. And Arvin, for students that are thinking maybe direct to PhD is the way for them, what would you say you like best about the PhD program?
Yeah, I think the overall learning experience, and there's that freedom to kind of explore new ideas, and also you're able to realize that as a system, like a workable system. So all of that, and also I would say like learning different technical skills, for example, becoming better at programming, becoming better at coding. So all of that, I would say. And probably lastly, I just want to add something similar to Ebru. When you're really discussing the ideas with another person in your lab or from another lab, is when you get the most creative ideas, and then you can take back that inspiration and apply that in your own research.
That's excellent. Thank you, all of you. Those are very insightful. I think we have time for one last question. Ehab, I'm going to give you the honors. We mentioned when contacting or trying to get in touch with faculty members and, you know, discovering the way they work and learning from personality matches, and they want to contact students that are currently studying under a faculty member. How would they go about finding the name maybe of a prospective student to contact?
Look at the publication list. The names in the front are students in recent papers.
Excellent. Perfect. Simple.
Some of our labs as well have websites that list current members explicitly.
Right, going onto the lab websites and finding the lab members. Excellent. Okay, well, that wraps up our Ask Me Anything event for the Department of Systems Design. I would like to thank all of our panelists for their time and insightful answers to all of today's questions. Don't forget, if you haven't yet registered for our Waterloo Engineering Graduate Studies Alumni Panel, which is happening this Friday, November 5th from 12 to 1 Eastern Daylight Time, you can still sign up to attend. We will attend the link and we will add the link and the information to the chat now. This virtual event will feature alumni panelists from our graduate programs who will speak about the impact their graduate degree had on their career path. Thank you once again to all of our panelists, and we look forward to welcoming you to Waterloo Engineering in the near future.